Good morning, everyone, and welcome to today's session. This is the first and probably more than one on the component type part of the roadway designer. We're going to start at the beginning level with this and try to run through a simplistic little overview of how this works so you have a feel for it. The components are a very, very powerful part of our new roadway designer, and we will have additional sessions on things like constraints and end conditions and that. So we can't cover everything in an hour, so please sit back and try to if you take a look at this, and if you have questions at the end, we will address them. We'll try to. Okay, today's agenda. We're going to begin with a definition of components. So we just will clarify what components actually are, or what we at the En-ROADS team think they are. We're going to go over then simple components, constrained components, and unconstrained components. So when you hear that terminology in the future, you'll know what those type of things are. We'll look at what null points are, and we'll also look at what end conditions are. And then in the end, we'll look at some examples of component combinations which actually create templates. Okay, to begin with, we'll look at the definition of components. Components are a set of named points. They can be closed or open shapes. In other words, you're going to see we'll have options that we can close them or open them, and they can be constrained or not constrained. And we'll look at what constraining means. It's possible to define both conventional backbone and exterior with these. So those of you that are familiar with our like our backbone class and our side slope class, these are where you actually do the backbone and the side slope, except now it's possible to combine these components and make templates. So we've kind of broken it down where at first it may look difficult, but after you use this a little bit, you'll much prefer using a component approach versus a template that has to contain everything. The components can be used in volumes, they can be used in cross sections, and they can be used for stakeout. And we'll discuss lightly how that is, but basically the components come through in the DTMs. They're a child of the DTM, and they're not actually triangulated models, but the features come through as an exclude from triangulation. Okay, it's also possible now to create 3D type shapes such as retaining walls, curb sections, special subgrade sections, things that in prior versions of En-ROADS would just about be impossible to do, or would take an extremely large number of layers to simulate. Okay, so let's start out with a first item. This is the simple component. A simple component is basically a basic parallelogram, which I'll bring up here in a moment. It has a predefined thickness, slope, and width, and it's constrained based on predefined settings. Meaning as we build this, the settings in the predefined thickness, slope, and width, that's what constrains the information to its adjoining points, as we'll see in a moment. And these simple components are generally used to define layers such as the asphalt, the base, the compacted subgrade. All points do contain names and styles, or I should say can and should, and defined points can be used in what's called an alternate surface creation process, meaning you can define any route you want to create a model other than the top surface model. Okay, let's go over here for a moment and look at the information we have. I'm running the En-ROADS 8.7 that is in delivery right now up on select, so I'm not running anything that you can't get yourself. I've got a geometry project loaded. It's a little subdivision to just start with, and what I'll do is I'm going to just display everything, because right now I have nothing displayed. I wanted to show you what we're working with. So we'll go to Geometry View, Geometry, and we'll do some horizontal annotation quickly. Now in the horizontal annotation, all I'm going to do is turn on the elements. I'm going to touch include, and I'm going to do a filter right here. And I'm going to say swap. Now one thing, we generally like to touch on lots of areas as we do things. Up here now in these preferences, it's possible to save your queries and what you set up. This is a huge item for those that do a lot of subdivision or anything where you do specific queries and you want to re-execute. So you could, in other words, save like utility easements, lot layouts, right away, so that when you go to select alignments, all you do is select preference and load it, and then the filter's already built based on whatever criteria you used. Okay, so we've got that. We'll take everything, we'll just look at it all, we'll turn the right lock on, display it, and we'll fit it, and we see we've got a simple little configuration here. And if I look at it just briefly, I'll just right click on, well, let me get one of these. We'll go review, and I'll set it on element. We can see right here we have just a straight alignment there. This Aubrey is the one I'll probably run the modeler on. We start out right here on a piece of tangent, and then we roll into a curve. You can see it walk along. You've got all the geometry, so they're very simple geometry. So we've got our base geometry. The next thing we'll look at for a moment is our base surface. I'll look at the perimeter of existing ground. We'll fit that, and there you can see the area we're going to work in. And one other thing, we'll take a quick look at the contours here. And I think it's kind of good to put things in perspective. That's why I'm just showing you what we're working with. We'll take a look, and you can see here's the surface that we're working with. Those are the roads. Now let's take one moment and let's look at a backdrop. Now what I'm going to do is select reference, and here I'm going to cover something else at the same time. Slide down. I'm going to go Tools, Attach. Now when I attach, this is one thing. If you work in the same coordinate system, or if you're like US feet versus international, whatever, you've got to watch if you do the coincident world, coincident, or interactive. So if you had different units, if you go coincident world, for example, you've got to make sure that you're doing the true scale attachment and all that type of stuff. Here I'm in the same units. I'm going to just do coincident world. I'll attach this file. In fact, I'll load the big one, and we'll load it up, and then you can see the backdrop of the information. So this is actually a subdivision, and what we're going to do is come through here and model with the typical sections, creating components, a simple typical county spec roadway. Okay, we're going to start, like I said, at a basic level, and we're going to model, and we're going to take a look at where the cut fill lines intercept, look at some sections, that type of thing. Alright, so we've looked at our data. We can see we've got information we're working off. All I'm going to do now is just turn that off. We don't need it on. I just did it for backdrop. Okay, so there we've got our geometry, and we're sitting with a DTM. Alright, let's go to the first step, which is the modeler. We'll hit modeler, and we're going to go to create template. On the create template, what we'll see is a little dialog like this right here. And the template, if you have an older template you want to bring in from the previous versions, we have an import TML option. So if you want to just get back and experiment, you could import your existing template libraries. But when you look at what we're going to do with components, you may want to rethink that, because you're going to have everything together. So let's just start out here. We've got this file called an ITL. That's a template library, Inroads template library, okay? And you can open one, or you can come up here and do a new one, template library, or folder. And so we work in this tree structure, and these are just a little example I put together to show you how this works. So the bottom line is you create a component library, or a template library. You right click like this, and you can say new folder, and I'll just say for class so you can see it come in. So you would have, just like you do with Explorer, for class. Then you touch for class, you right click, and you can say new template, and see that's a child then under that. So we'll just say temp1, okay? And we'll do another one here and right click, and we can say template 2. So you get the idea of how you can create them. Now that's fine and good, but I want to show you something you may want to look at as you do this. What I like, after using this a little bit, is that I can come over here and make something called components. In the component, I put a singular item, and actually watch in the bottom view. You see this is the preview. When I touch down here, with one touch, we see the information right here, okay? But if I go back here and I double click, then it shows up over here in this view that we can do edits in also. So here is the preview over here, and if I touch another one right here, see something else can come up, but the other's still there. So you're going to want to double click like that. That makes it show up. And in the lower left pane, these are the view things, very similar to MicroStation itself. Like here's the window area. See the tooltips pop up. Here's where you can do the different zooms. So you can zoom in and zoom out. You can zoom in the X or Y direction to change the scale. If I pick a thing like this window area and I come up here, it takes me there. If I hit the fit, just like in MicroStation, there's everything, okay? Very simple. Okay, so let's talk about what we're doing here. Under Components, what I recommend doing is setting up just simple little elements that you're going to use in a combined typical section. So if you notice here, if I touch this, here's a 26-foot wide section, here's a sidewalk, and everything's based on scale. So it may look huge, but it really isn't. It's just blown up so you get maximized view, okay? So we make all these typical things. We also, we're going to come to this in a little bit, have an area where we set up what's called end conditions. So we have different conditions that happen. These are like your cut fill tables and that. We'll come back to that. But you'd have a component and an end condition area, and then you're going to have typical sections. And even under typical sections, like this right here, typical sections, I can right click and say folder, and I can say levies. So if I was going to do a bunch of levy work, I could come over in the levies right here, right click and say new template, and I could say top 4-foot levy. So we could have a levy like that, and then reach up into here in our components, grab data and slide it down into here. So we're gonna run through all that in just a moment. Okay, what I'm gonna do on the components right now, so you do get the idea of the structure. I'm gonna go to components, I'm gonna go right click, and I'm gonna say new, and I'm gonna say new template, and I'm gonna just say curb -1. So I've created this. Now if you notice, there's nothing here at the moment. I can put a description on it, and I can say this is for class training. So I'll do that, and so far I haven't done anything other than just create a template. I'm sorry, a component, no, a template. But in the template, I'm going to put a component. So when I right click right here, and notice based on where you're at, the right click's different. I'm right clicking down here. If I go up in the open screen and I right click, then I have access to these type commands. So I'm going to go right click, and I'm going to say simple. The first thing we're going to go through, a simple component. Okay, just look, by default what we have is a parallelogram. Okay, now this has true 3D, because where my mouse is, it goes straight down to the bottom part. And why is that? That's because of the slope, thickness, and the width right here. So this right here we could just label or name asphalt. Now this name right here, it's important to note, comes through in your volumetrics. So when we do run the roadway designer and a component was named asphalt, or any subsequent components also that were named asphalt, this information will come forward. So here's asphalt, and generally you're going to want to put a feature that matches that. Notice how it, let me do another change. See, it's white. Now what you're going to want to do, so you can keep track with things, is set your styles up so they match the colors you want for the different things. So notice here I'm yellow, that's what I want. So I've got a component named asphalt, and this is going to show up in my volumes. It's a 2% at 0.4 foot thickness, and let's say I want to make this a point, I'm going to make it large once just so you can see it blow up. When I go 0.8, what happened there? See how it got thicker? And let's say I'll back it off to 5, a tab. You see how that changes it dynamically? So right here you can change dynamically the way things look. So I'll go 0.25 and I'll go back to 12. or actually that was 13. So I'm back here like this. You can see what it looks like. Another thing, right down here, if I slide over it, it says toggle on off dynamic settings dialog. So if I touch that, this little dynamic settings dialog pops up. This applies to all the constraints, components that we're going to place today. So this is the key. It's similar to the MicroStation Precision keyends, however it's oriented to civil engineering, so it honors those type of keyends. So what I'm going to look at first is what's called a step. A step, if I make that a 1, we'll tab that in 1. What happens, notice when this jumps, it jumps in series of 1. You see that? So it's jumping on the grid in series of 1. Let's make it a little bigger even. We'll go 2 and 2. So see, it has to go a long ways to make the jumps. Let me slide one more time. It can only jump by increments of 2. 2 being the master unit. So what I'm going to do is I'm going to back this off, and I'm going to make it a 0.2 and a 0.2. Okay? And what this is, over here, it's XY step, or it's X, meaning this back and forth, and slope. So you can lock the slope down so that it's a series, just like our vertical design tools, actually. I'm going to set that at 2%, just a second here. And then what will happen as I change values, then it's going to be locked down to step in the 2% range. But I'm gonna put this actually back to an XY with a 0.2. Take this little point that my cursor is on, and I'm going to take it right up here, and I'm going to set it. Notice at the dynamic setting box how it says XY00. See this right here? Look, if I'm over here, it says 3.4 minus 2.6. You can put these components anywhere you want, actually, because if we're just doing component at a time, you can just grab the vertex and slam it in on a template, which we'll look at in a little bit. So as I go, if I want to just place a template like this, I set it there, and then it's at 0, 0. I accept it, and there it is. So if I fit it now, there's my template. Notice how the scale changed. If I hover over it, the little palette says it's asphalt. There's a slope, there's a width, and there's a height. Okay? So we know what it is. Up in here is where you can turn on the component. Is this actual element that we just created. The constraint we're going to look at in a minute, but a constraint, what that really means, with all the template kind of stuff we did in the previous versions, you really were running with a constraint, relative to the neighbor, except point to point was relative to its neighbor. So in other words, this point right here, you see how it's red, that means it's constrained. That point right there tells it that it comes down here an offset of 0 on the X, but an elevation of 0.25 down. So the constraints are both horizontally and vertical, and they're constrained from that point right there. Okay? If I come over here, I have a similar situation. That's constrained 13-foot offset with a 0.26 down. And then this one is constrained to the one just before it. So that, what that is that tells you how you can lock these down. And we're going to get into constraints somewhat in a little bit. But you can build all types of constraints. Now what I want to show you for the discoverability of this is that I can touch right here on this point, right click, and then at that point I can do an edit point. It brings it up. So I can see the point name is 3. Now if I didn't like those names, I can name it anything I want as I go. In fact, let me start over here right at the top. I'm going to say edit point, and we'll call this ASP underbar CLRD. Okay, asphalt at the center line. There's no constraints on it. In reality, the probable only constraint would be the attachment to the profile grade line. Okay, so we've got this, and right here is where we could add constraints if we want. We'll come to that in a moment. There is one button here that I'm going to go over on different points, but it's called Include an Alternate Surface. This point, if it's the top point in our template, when we combine the components, by default it will come over in our design surface. However, if this was a sublayer and we say include an alternate surface, it can also create a triangulated underlying surface. So that's what this include an alternate surface does as you create things. So if I hit apply right there, and I come over and say display names, oh, I forgot to leave this dialog. You see asphalt centerline road. So then if I just come over here just for a moment, I'll just do one more, and I'll say ASP underbar R1 or RT, R for top. And I'll hit apply, and then I'm gonna go next, and I'm gonna do this one. I'm gonna say ASP underbar right, and then I'm gonna say bottom, and I'll hit apply. Now what that does is as the modeler runs and generates the longitudinal features, then the name can be derived from that. And what would happen is that I would see a feature that's ASP underbar right top, ASP underbar right bottom. And the right bottom by default would be exclude from triangulation, whereas the right top would be in the DTM. Both will be in the DTM. One will be marked exclude from triangulation, the other will be triangularized. Okay, so we've got that, and now we'll go back to looking at just the components. Now we've got to display all if we had several of them in here, but we're working with one. And I want to say, the way I'm showing this is not the only way to do it, of course, but I think when you look at it, you're going to like to do these singularly. So let me start over again. And what I'm going to do now, I'm going to just touch this, and I'm going to say delete it, because I was just showing it to you for a moment. One thing I'm going to do now is come up here and go to options. On my options, if I want on seed name, I can do it this way to start with. So I'm going to say ASP 1. We'll just go asphalt. And I can apply affixes for left and right. And so right here I'll say L, and I'll say R, so I don't have to label left and right. I was just showing you how you could do that. Okay, and the component names can be derived from the style we select, or you can specify it. So we'll just say OK with that. Now let's do this one more time. I'm going to right click, and I'm going to say add component simple. This time I'm going to do it a little bit different though. I'll name it asphalt, ASP, or asphalt, I'm going to come up here, and now notice I'm on a step 2. I'm going to right click, and I'm going to say mirror. See, now they're together. So when I come and steps of point 2, see how the steps are coming? Okay, if I come like that, now notice on the lower right where it says dynamic setting, it says 0, 0. If I place it right here, let me back up, it's 0.4. You see that? So that's actually a positive and a minus 0.4. Let me get it back to 0, and that's where that step came. Accept it, fit it. Very simple, you all know that. And notice how the automatic naming kicked in. Okay, and it's actually got the L's and the R's on here. Okay, in fact, one of our previous sessions, someone asked, what do I do, or what happens with this common point that's got 2 points there? Okay, well, I would ask the same thing. It's very obvious that something's got to happen here. There's a left asphalt, and there's a right asphalt. You see the R and the L, and the material's asphalt, period. So if we went to volumetrics, we just have asphalt. Now, when I hover over things, if I right-click, because I'm sitting on the line, it recognizes we could probably merge this. So I can say merge, and that just now became one component. And that just resolved my duplicity on my naming. So now if I hit edit point, I've got one point there, and it's not constrained right there, and you can see we have one element. Okay, now let's say we're building this, we've got a component, and I'm going to hand it, I'm building all this, and I'm going to hand it to somebody. I could come in here, just touch that component with a left mouse click right there, I double clicked it, I can come in, take a look at it, I can put additional information, a different type things, all types of things on it. In fact, I can even do what's called display rules, which we'll try to touch on here in a moment. But I'm going to just simply right click here for a moment, and I want to remember what this thing is, so I'm going to go to what's called template properties. On template property, this is really neat what we've got here. This makes this much easier to follow what's going on. I've got a simple little document here called a layer.doc, a document file with an image in it. So I'm going to just grab it, and what I'm going to do is I've just now associated that with this component. So if I come back here now and I right click and I say template properties and I say open it, what will happen is I will get the picture and any information about it. Now, I'm giving this a second to come up. So you see the image and you see the little example of how you can attach Word docs. You could have a verbal AVI or a WAV file, anything attached. So when you click on the component, you could say, use this component to do rock shatter in a permafrost area. And then you could have a little image or a AVI that shows how it runs. Anything you can link, you can stick in here. So I really like this, and in terms of setting up standards, this right here can make a huge difference in standards. So be aware of that. When you get the software, all you have to do, right-click, template properties, and attach anything you'd like. Okay, so this is a little example of where we might come in. In fact, see, I've got this one active right now, and I didn't do curb. I need to change that, and I need to say that that was asphalt. Asphalt layer, I'll just say that. So now when I archive this information, that's an asphalt layer and I know it. At any time I can come up here and just say save, and then it saves that template out. Okay, so real quickly, just to reiterate, if I go new component, simple, what that is that's a closed shape. We all know that. One other thing, you can see that. If I want to, I can right click here, turn mirror off. Now if I want to just put the left side, I can right click and say reflect, and then you see how the left side comes in only. So any feature you can reflect like that. Only draw it in one direction. Instead of drawing a right and a left side, you can draw one and just say reflect, and boom, it spins it. Very nice, very easy to use. Okay, and then here I'll just say cancel. And then just like everything else, any of this stuff you can get on this. And obviously you've got edit points, so you can come in and edit it. You can add additional constraints. And now let's talk about that just for a moment. On constraints, you can have full constraint, meaning it's locked down absolute from a horizontal and vertical, or you can lock down just horizontal, just vertical. You can lock it down based on a slope or a vector offset. You've also got the horizontal max and minimum and the vertical max and minimum. So what this actually means is, in one of our more advanced classes we'll do it, things like overlays and that, you could set vertical minimum or vertical max, and you could come in here and have one point influence another point based on an existing as surveyed DTM. So you can target all types of features, lots of different ways to do things. We'll come back to that. Okay, so that was a simple template or a component, and that's not intended to be run. That's where we come back and we combine these series like I've got here. Okay, what's going to happen is you're going to come back and combine. There's that yellow piece, there's another one, there's a curve, all this other, it combines. But instead of me having to think all this through, I do it in a much simpler way up here. And then plus I can reproduce it and put these attachments on to explain what it does. Okay? Alright, let's go back here for a moment. So we've just gone through a simple component. It's a parallelogram. Just remember that. Okay? And you remember how the constraints, I'm not telling it what the constraints are, it just brings them in. And because it's a parallelogram, it locks it down horizontally and vertically. Okay? Constrained components. A constrained component is a different beast. It can be either an open or a closed shape. So you can just draw lines, or you can draw shapes that come back on themselves. We'll look at that. All the points are constrained during the creation of the component. That's the main difference between a constrained component and an unconstrained component, is that when I place the component points, they're automatically constrained relative to their neighbor. The points can be used in alternate surface creation, which we've just looked at. The dynamic settings are the key to laying out the components. And we're going to look, and I'm going to show you how the help is set up where you can easily pick this stuff up and do it immediately after this class or session. We can look at also how they can be used to compute the volumes with the components when it is a closed shape, or if it's not a closed shape, how we can use an alternate surface or a top surface to use an open shape. So either way, a constrained component can be used in a volumetric computation. Okay? So let's flip back here for a moment. And I think you know what I'm going to probably do. I'm going to come in here and I'm going to use this component folder again. I'm going to right click and I'm going to say new. I'm going to say template. Even though that's a template, it's really being used as a component, okay? Some of the terminology may be a little confusing sometimes, but a template can be a combination of components or a singular component that's used to be combined with others. Okay, let's just do a real simple thing like a curb. Curb 1. And I'm going to come back here just for a moment, a curb standard. And I don't have rounding or anything in it. I just built a simple little curb. We'll build something similar to that over here. So we double click and we're active in here. And one other thing, you notice this active, or this little purple dot. What that is the dynamic origin. And what does that mean? Well, if I look over here for a minute, because what I'm going to show you now is the key to any precision placement. XY is relative to the dynamic origin. DL, well, we'll look at these. We're going to just look, because I can't remember them all the time. So if I don't know what that is, I'm active in here. I can go to help. And the help is very good here. So we can come over here. We'll slide down a minute. At the bottom of this, I'll let it catch up for a moment. You're going to see the information you need relative to how do you find specific areas to execute the command. So it's very discoverable. So let's look here for a moment. What I'm looking for is dynamic settings. So I'm going to hit dynamic settings. Okay, what's the dynamic settings? We've talked about the XY values, how they dynamically step down through a template creation. But now let's look over here for a moment at the key-ins. That's all we want to look at for the moment. Okay, it'll catch up here in a second. Now these key-ins, this is all in your online help. So I mean, this is the way I recommend you pick this stuff up and learn it, is that you use that help. You really need to use it so you know what it is. So I'm going to just sit here. XY key-ins are absolute coordinates. DL key-in are delta coordinates from the last point placed. So like if you're using microstation placing a line string and you go DX or whatever, then the DX is from the last delta. HS is the key-in, but it was DL in this dialog. HS is the horizontal delta and the slope from the last point placed. VS is a vertical delta and the slope from the last point placed. So you can work as you would normally work as an engineer and place things in at a slope and a distance. And the other would be delta coordinates from the dynamic origin. So you can move a dynamic origin anywhere you want it and use this OL key-in and be relative to the dynamic origin. Now that's real neat. So you don't have to compute coordinates. You could have a point at a center of a retaining wall or whatever that you want to radially go about, and you can do that with an OL. And the same applies with a horizontal distance and slope from a dynamic origin. You can move the origin anywhere you want and then move with distances and slopes from that. So what was done here is it was it was accomplished in providing the person that's building these components to give them the tools to key it in just like off a set of plans. So if you take a set of typical sections using a combination of these key-ins, you can build the plans directly. All right, I'm going to come over here for a moment then, and I'm going to right-click and I'll say New Component Constrained. So as I place this thing, it's going to be what's called constrained. Every point that will be placed will be relative to its neighbor. So I'm going to say curb, and I'm going to say a constrained curb line. Okay. And down here on the current component, I'm going to give it a curb. And I'm going to come over here and I'm going to call this or use the feature for curb. And there it is. And if you don't have this in there, what you would do is simply add it to your preferences. Okay? So that's where the curb comes from. And let me say this, you're going to need to have the surface preference recognized. That's where this is going. So we've got curb, the style is curbed, excuse me, curb. And notice at the bottom it says DB for data button, place vertex of new component escape to go back. So here, I want to start naming these things right as I go, and I'm going to call this curb underbar CLRD. The point style, as I place it, is going to be curb. There it is. And then I can either come up here or I can key in 00 if I'd like down here. So I'm going to just place this one simple. So now we're started and we're moving. We're ready to put the next one in. Okay, and if I want to put a different name on this, I can say curb FC or F for just face. So I've got curb face, and let's say now what I want to do an XY. I want to go, we'll make it real simple numbers, like I want to go 0.4 feet, and I want to go flat. So I'll go 0.40, and that will put a curb F. Okay, so there we can see curb F. And actually I'm going to right click here. Notice it says finish, close shape, mirror, undo, all that type. So if I made a mistake, I could undo the last one. And another thing is maybe I don't want to make it closed. If I turn it off, then it's just hanging like this. But if I change my mind, I can turn it back on, okay? For right now, excuse me, I'm going to leave it off because it might confuse you what you're seeing. So here again, I'm going to come back and I'm going to go curb G for gutter. So I'm going to go curb G. And now I'm going to go back to my help because I want to remember something. I'm going to go down 6 inches and over an inch. So how do I do that? So I want to go key delta coordinates from last point placed. Okay? From the last point placed. So I'm going to use a DL. So I'll say DL. And I'll say 1 inch. If I go 1 inch, comma, down minus 0.5. Okay, minus, help if I key it in right. 0.5, and I hit an enter. When I hit the enter, it places the element, and it converted that 1 inch to the same units. So that was pretty neat. I wanted you to see that as it went. Okay, and now let's say we go over 2 feet, and that's again a DL. We go over 2 feet and up an inch. So we'll go 2, comma, yes, that's 2 feet and up an inch. So we'll go 1 inch. So I hit enter. And there we put the face in. Now we come down half a foot. So we go minus 0.5. Actually, see, I almost did that wrong. But in fact, I'm going to do it wrong so you can see this. In fact, I'll just put it 0.5, comma 2. I just totally did that wrong. I'm going to hit an enter. Okay, I made a mistake. Now what the beauty of this is, I've got 2 ways to go. I've got these undos down here if I stop. Or I can right click and say undo last, and I'm right back. So our development team did a great job making this actually usable, where you can, if you don't, if you make a mistake, which every one of us will do at one point or a time, you can fix it easy. So I'm right here sitting at that, and here I may just call this curb G2, and I'll call it curb, and I'm going to go 0, and I'm going to go minus 0.5. Put that in. And now I can come back. I've already gone 2 feet and 6 inches, so I can come back 2.5 feet, and maybe I just want to come back at a slope. Let's look at that a second. So let's use a slope. Let's come back here a minute. I want to use a distance and a slope. So I want to key in horizontal delta distance and the slope from the last point placed. Okay? So let me reactivate over here. And I'm going to come over here and see, I already forgot what that was. That was the HS. So I'm going to flip this guy to HS, and I'm going to say minus 2.5. That's my distance. And I want to come at a minus 2% slope. Okay? So if I hit a enter, I may not have been active there. Just a second here. I probably dismissed this component as I was going. Let me get here at a point at give me 1 second. Now I have it right back. I actually dismissed this, so what I would need to do there is just come back in, and the bottom line, as you can see, you can come over here and you can play with these add them any way you want. Now at this point, if I come in on this component, let me get back to it, and I say edit the component, I can come in, I can change the information so I can make it closed. There I made a mistake, so what I would do there is I come back up here and I can say move point, edit point, delete point. I can do all the different things I want to edit it with the standard editing tools. Or if I just plain don't like it, I can touch it right there and I can say delete the component. Let me get back on that. Components, this is delete component. Should delete it, okay? Well, I've got caught in some little loop there. That's no problem. All right, one more time. And right here is where you normally delete it. I probably stepped on something, but that's all right. There is where you can come in with a constrained component. And notice the reds, those indicate if I do a check on it, and I check an edit point, it says now it's constrained by horizontally and vertically these points. So you can see right here it went 2 feet and 0.08 up from the previous. And if I go next, that guy right there is constrained by that one, 1/2 foot down, the value is 0. So all of this you can come in and grab it and edit it any way you want. And at any time when I looked at that also, if I wanted to put the point in an alternate surface, I could come in and touch it right there and hit apply. And any of these, if you don't like the way it's constrained, you can come in and change it here to a different feature or to a different style or to none. Okay, so real quick, I know I didn't put this down like I wanted to. All it was, real quick, is come in similar to this so you're referenced up here. And it's just a matter of, just like MicroStation, basically, of insert point and edit. So very simple. I don't want to take the time on it due to our constraints on time here. Unconstrained components. Okay, what is an unconstrained component? An unconstrained component can be an open or a closed component, and all points are not constrained during the creation of the component. That's the #1 difference. So between a constrained and an unconstrained, as you put it, the points aren't relative to each other. They're just out there, all right? So when would you use it? When you're pretty much free-form designing stuff versus you want a sequential component tracement. This one could be where you're kind of free-forming it relative to a point that's not the previous point. So unconstrained can be used all over. You can put them in the alternate surface. The dynamic settings are all used just like before. You can use them to compute volumes when they're closed, or if they're as a closed component, or you can create the alternate surface or top and use it when they're not closed. So real quick, let me come over here. I'm going to just create another component, and I'll go template, and I'll say, let me see, we'll go, we'll just go curb -2, because I just want to give you a quick example. I'm going to move it pretty quick here. I'm going to go unconstrained. I can say curb, everything looks good. I can give it just an example. And you saw how we could put names as we go. We can start there, start right there. We can use any of the key-ins that we'd like to bring data around. But I'm going to just place some points so we can look at them. Now right here, if I want to right-click, I can say close shape. So there, we've got a closed shape and we're still moving around. And I'm still moving around. If I right-click and say finish, it's done, okay? And if I look at it right here, I can come back and I can come over here, and this is where I could simply put a link on like that. And now that thing will have whatever link you want relative to it. Now the one thing about this versus a constrained one is, notice the color of the points, they're green. The other ones were red. If I step back here just a moment, see how these are red? So I come back to these green ones here. If I touch a green one and right click and say edit point, if I look at edit point, the constraints are none, okay? That's because these are non-constrained, and so it's jumping around on these, and none of them are relative to the other. So if I come over here, touch it, right click and say move point, It's just like inroads alignment move PI. The local tangents move, see? It's not like the traverse edit that moves everything with it. So that would be with these constrained components when you move them. But with unconstrained, it moves like this, okay? So that lets you move these around, and at any time, if you want to constrain them, you can come in here and do the constraints, place it on there. So if you edit a point and you want to constrain it horizontally, you could come in and pick a point to constrain to, or any way you want to do it. The different components that are in different, or different features that are in different components, you could come in with a parents. Now we're not going to get into parents today due to lack of time, but if we come over here on help just a moment, because there's a whole lot of different things in here. What this is, you can, when you look through this, you can come in, I'll wait a second for it to catch up, but you can come in and specify different things that you want to be relative to. Now this is where you put these probably in the same template, several components, and you're going to use them as a parent 1, parent 2 to constrain other components. So this is a very powerful way that you can associate vectors and offsets from one component to another in a template. Okay, we'll come back to that, where the template comes from. So there's an unconstrained. You can see quickly how that popped out. And let's just do one more unconstrained. Now this one, I'm going to just put it out here like this, and I can just right click and say turn the closed shape off, and then right here I can say finish, and then so you can have a component that's not closed like that, and then you can use that to associate it with other things. Okay, alright, so let's go to the next one. And actually our template creation lecture that we did should somewhat show you how you could take these components and drag them together. Alright, next item coming up is null points. Null points are points that can be referenced for controlling other components, or component points. These are like the phantom pivot points in super elevation in the previous versions of inroads. These are points that don't have to be used other than for referencing purposes. Difficult design scenarios can be solved using these null points as constraint guidelines. So let's come back here for a moment. We'll look at this. We've got these simple little scenarios here, but if I right click now and I say add a new component with which is a null point, I can come in here and just say control, and I'll still use the curve setting, but I can set this anywhere I want, and I'm using steps, or I can use a precision key in. But if I want to point right in the center of this shape, if I set it right there, I can use that shape then to associate offsets or vectors to any of these other points on any of these other components. So you can, if you're doing widening and you're not going to produce a portion of a lane or whatever because it's a stage construction, you can put a null point there and still use it for shooting down vectors and that to do your construction work. But even though you don't have to compute that part of the model. So it's pretty neat. In fact, let me just do one quick little thing here. I'm going to just sketch this in with this tool. I'm going to go with a unconstrained, and I'll just call this pavement. And I'm not going to worry about the style or anything. I'm going to put in a piece of pavement like this right here. Let's say we're coming through like that. Okay, we've got one, finish it. And I'm going to do another unconstrained, and I'll put this guy right here. Alright, so we'll finish that. So we've got this right here. When the job is actually produced, it's going to project up to here, okay, and then connect up over here. But with this null point right here, we can run what's really being built and then send a vector down over here, so we could run another line that intercepts through here from that null point. So we could have from that point to that point a vector, and take this point right here and intercept that vector, and not have to build the whole model to do it. So we could do stage construction with these null points. Anything that you can sketch out because you can put a null point, you can generally solve. Okay, so the null points are very handy tools. Okay, next thing is end condition. The end conditions, I'm going to let it come up for a moment here, are the exterior portions of a model, generally speaking. That's not really true anymore, but generally speaking it is. This replaces the decision tables, the cut fill tables, material tables, and the exterior template intercept techniques. So when you hear of an end condition, that's what that is. Really, that means you're replacing your decision table or whatever. And if you take and import a template library with decision tables, it will bring it in, make components of each decision table, and make it where you can use it in the new modeler. Targets are available just like decision tables. You've got all the X, Y, Z targets, surface targets, that kind of stuff. Now, the priority value is what it does the what-if testing. So in a decision table, you would do the first target block series, and then the next one, and the next one. And the first one that catches is the one that you would use, that would be your solution. With this now, you just do a priority deal. Priorities come through and enable you to set priorities of which one catches first. There's also a testing dialog available. And now here is the difference on that, what I said about generally speaking. You can have more than one set of end conditions in a template. That's really neat. In other words, you can hook up these component types we've just looked at with the results of other end conditions, so you can do some really neat stuff. Okay, we're going to come over here for a moment, and I'm going to just turn on one of these end conditions. When I look in here, I've got a component. It's a fill section. It's got the 3 segments through here, and you can see like this point right here is fully constrained because it's red. If I look at edit point, you can see it's got the constraint of slope from point fill 1. It's a 2.1%, and it's 2 foot offset from that point. If I go to the next one, this is a 33% with a 10 foot. In fact, let me back up one. Notice right here, just like a decision table, in fact, I'll even back up one more. Here's where we start. We start right here, and we say from that point, the feature styles fill, check for intersection, just like in the decision table. Place a point at the intersection, and here's where you can do a do not construct if you like to go that way. At the moment, we're not constrained to anything. We're going to just place this in a template. When I go next, I say check for intersection, place a point at intersection, but I don't have do not construct on. So it's going to find the intersect, put a point, and that could be the end of it. Next one is the last one. I say check for intersect, place a point, and this end condition's infinite. So I don't have to put a huge number. I just put 10, but I said it's infinite. That means go forever and look for an intercept. If you find it, take it. So what that means is in this fill condition, if I do intercept, it's over. Okay? And this is simply with edit components end condition. I just select that and just place the vertexes. Now if you look at a cut section like this right here, if we look at the edit point, we can see we're looking again, but when I go next, then you can see we've got the 33 at 10 with an end condition of infinite on the last point. Okay, so very simple little example. Now let's look at, because we're getting close on time, how we do this, how we take these. I'm going to come over to my typical sections in roadway, say new I didn't mean to do new folder, and all I have to do there is delete it. Yes, I'm going to say a new template, and I'll just say class. So I've got a template class, and let me come in here, and I'm going to come back and grab my components now. So I'm going to come back and grab my asphalt layer, and notice I didn't double click it. What that means is class is the active. You see it right there? So I'm going to grab that point, And see, I can move that point anywhere I want, but I'm going to grab it from the center, drag it in, and look at my dynamic setting coordinates. It's 0, 0. That's where I want it. It's placed. I'll fit it, okay? Now let's move pretty quick here, and let's come in and put in a 6-inch compacted base. I just touch it. I'll grab it. I'll slide it up here, and I'll fit it again. And there we've got our base. Now I'm going to come over here, and I'm going to grab a compacted subgrade. I'll grab it here, drag it over here, fit it again, and we've grabbed that component, put it there. Now I'm going to come back and I'm going to grab one of my curbs. Now here, see how you can move around on this? I'm going to grab it by the face. Now watch what I do here. I can do it individually, or I can right click and I'll say mirror with my right click. And so as I move across and I get in place, I just put both sides in. Now see, I've got a little issue here, but maybe I wanted to do that. It's depending. You know, you can change that. So we've got these. Let's fit it again. Now we need an end. Well, let's say I want a sidewalk. I'm going to come up here, grab a sidewalk. I'm going to grab it right there. I'm going to grab it up here, and I'm going to right click and turn that mirror off. I just want it on my left side. Okay? So now I've got a sidewalk in place, and now I want to do the cut and fill scenario. So I'm going to come in. One thing I didn't show you here, let me hit that. If I touch this and I look at template properties, oh, wrong one. Just a second, edit component. If I look at the edit component, it says priority 1. That means use that first. If I look at the fill, the berm, and I look at the edit component, priorities 2. So if the cut doesn't work, use the fill. That's what I'm saying. So let me put it back here on class. I'll activate it, and I'll come back, grab the cut, and I'm going to grab it by this point, right click, and I'm going to say mirror it. Now see, that isn't working. That's not where I want it. So I'm going to right click, turn that off. I'm going to hook it on there. I'm going to do it again. Grab it, right click, and I'm going to say reflect this time and hook it on the end of the sidewalk. See? There we go. And one other one, I'll grab the fill. I'll grab him right there. I'm already turned that way, so I'll hook it on there. And I'll grab it in. See how it's turned that way? I right click, reflect, come over, put it there. And now when I fit, I've just built the typical section from my components. So real quick, you get an idea how you can build components and then build typicals. And then, so we just went through an example of a standard roadway. You can do barriers, retaining walls, divided highways, many ways to go now that you couldn't do in the past. In conclusion, En-ROADS version 8.7 is capable of very advanced corridor modeling with the advent of these components. And you can see you can build any standard component provided across an organization, provide those links on it so people know what it is, then come up and let that be used to create the templates. So you wouldn't necessarily do templates for everything. Let the engineer design the template they want from the components, which is unique per project. And this concludes today's session on building components.